Our Sun, with a diameter of 1.3927 million kilometers and the center of our solar system, is now dwarfed by the recently discovered star by NASA. This massive star is 1,700 times the size of our Sun and will astonish you. Join us on a journey through the cosmos as we explore the largest star in the universe, compare its size to other celestial bodies, and imagine the impact it may have on our planet. Get ready to be amazed by the sheer magnitude of this remarkable discovery. Cosmic sizing. That's what we're talking about today. When it comes to star size, it can be difficult to determine how big they truly are. There are different ways to measure a star's size, including its mass and its diameter, but the results can often vary. First, it's important to understand that there are different types of galaxies, each with its own collection of stars. From spiral galaxies like the Milky Way to elliptical galaxies like M87 to irregular galaxies like the Large Magellanic Cloud, the size of stars can vary greatly depending on their location. Scientists typically use two methods to determine the size of a star: measuring its mass and measuring its diameter. It's essential to remember that the largest star in terms of mass is not always the largest star in terms of diameter. VY Canis Majoris, for example, is one of the largest stars by mass, but its size is still much smaller than UY Scuti, which is the largest star by diameter. We'll get back to it later. So, how do scientists figure out how big a star is? To accurately determine the size of a star, scientists employ a variety of methods, each with its own set of advantages and disadvantages. Observing the brightness and temperature of a star is one of the simplest methods. Scientists can estimate the size of a star by measuring its brightness and its temperature. Another approach is to examine the star's spectrum, which contains information about the star's composition and size. Another technique is to use radar to bounce signals off the star and measure its size. This method is especially useful for very distant stars that are difficult to observe directly. Moreover, based on properties like mass and luminosity, scientists can use computer simulations and models to estimate the size of a star. Did you know that having accurate measurements of the star is key to unlocking the secrets of our universe? It's true. Knowing the size of stars allows us to learn more about their age, composition, and even predict their future. But you might be wondering, which star is the largest? Meet UY Scuti, the largest known star. UY Scuti isn't just any ordinary star. It is a celestial marvel that has captivated scientists and stargazers alike. It is a true cosmic marvel due to its massive size and its luminosity. This red hypergiant is located in the constellation Scutum and is part of the Milky Way galaxy's Scutum Crux arm. It was first discovered by astronomers, and its size and luminosity have been confirmed through observations and calculations. Its diameter is truly incredible, measuring approximately 1,708 times the size of our Sun. This makes it not only the largest star in our known universe, but also one of the universe's largest objects. Its sheer size is mind-boggling, and it's difficult to comprehend just how massive it truly is. With a surface temperature of only 3,700 degrees Kelvin, UY Scuti is surprisingly cool in comparison to our Sun. This is due to the fact that it's nearing the end of its life cycle, making it a red hypergiant. These stars are unique and fascinating to study because of their low temperatures and their high luminosity. This red hypergiant is so big, it would stretch beyond Jupiter's orbit if it were plopped into our little corner of the universe. And get this, it would be so bright, it could turn day into night, and make the stars in the sky look like tiny fireflies in comparison. But UY Scuti isn't just a big glowing ball of gas, it's a mystery waiting to be solved. This star, you see, is one of the few that scientists have classified as a variable star, which means that its brightness changes over time. Nobody knows for certain why this occurs, but it is believed to be due to the massive pulsations and instability in its outer layers. But before UY Scuti took the crown, the previous largest star known was VY Canis Majoris. This red hypergiant is located in the constellation Canis Major, with a surface temperature of only 3,500 degrees Kelvin. VY Canis Majoris is also a cool star. While UY Scuti and VY Canis Majoris are the largest stars, it's important to keep in mind that there are other massive celestial bodies in the universe. Let's look at three more large stars. NML Cygni. KY Cygni, and AH Scorpii. These 3 stars are all red hypergiants, which means they're in the process of rapidly expanding and losing mass. NML Cygni is a star in the Cygnus constellation. KY Cygni, which is also found in the Cygnus constellation, is thought to be larger than NML Cygni. Meanwhile, AH Scorpii is found in the Scorpius constellation and estimated to be 1,400 times the size of our Sun. Because all of these stars are in distant galaxies, they're pretty difficult to observe and study in great detail. Their immense size and distance from us, however, only add to their mystique. You may be wondering, if UY Scuti is the largest known star, what is the smallest known star? Meet TRAPPIST-1, the tiniest star in our known universe. This little guy is small in stature, but he's big on mystery. TRAPPIST-1 is a star that is only 8% the size of our Sun, and it's only 39 light-years away from Earth. It is so small that comparing it to other celestial bodies would be like comparing a grain of sand to a beach ball. TRAPPIST-1 is not only small but also extremely cool. It has a much lower surface temperature than our Sun, which has a temperature of about 5,500 degrees Kelvin. But what truly distinguishes TRAPPIST-1 is that it is orbited by 7 Earth-sized planets. TRAPPIST-1 is therefore an incredibly intriguing object for astronomers who want to learn more about the conditions on these potentially habitable planets. The discovery of these 7 planets has also fueled the search for life beyond our solar system, indicating that there may be other solar systems similar to our own, with Earth-sized planets orbiting around a cool, tiny star. Teegarden star is the next one if you're looking for other small stars. This tiny star is only 12 light-years away from Earth and is about 1/10 the size of our Sun. It's so small and dim that scientists have had difficulty studying it, but it's thought to have rocky planets in its orbit. Another small star worth discussing is 2MASS J0523-1403. This star is so small that it's classified as a brown dwarf. The brown dwarf are like the misunderstood middle child of the celestial world. They are neither a star nor a planet, so what exactly are they? Well, these celestial objects are incredibly dense despite their small size, making them a fascinating topic for scientists to study. They can range from a size of 75 to 80 Jupiters, and some call them failed stars because they don't quite have the mass to ignite into a real star. Brown dwarfs have temperatures ranging from 2,500 to 3,000 degrees Kelvin, making them appear red. And they're pretty common in our Milky Way galaxy, with around 100 billion estimated to exist. Lastly, we have Ross 458. Ross 458 is an enthralling star known for its small size and its fast rotation. It is one of the smallest stars known, measuring only 17% the size of our Sun. Despite its small size, it rotates on its axis once every 4.2 hours, making it one of the fastest rotating stars ever discovered. This fast rotation is caused by its close proximity to a massive celestial companion, which acts as a gravitational pull, speeding up its rotation. Ross 458 is only 112 light-years away from Earth, making it a valuable target for future space missions and astronomical observations. We hope that you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.